Unit 15, Maintenance 4.0. So let's understand what are the different generations of maintenance. And today we are going to discuss about maintenance 4.0. That is the fourth generation in case of maintenance management. So these are the objective of today's sessions to introduce the maintenance 4.0 and the maintenance management, to discuss Industries 4.0 and its previous industrial revolutions with reference to fast industrial revolutions, second generation industrial revolutions, third generation industrial revolution, and the fourth generation industrial revolutions. The next we have to go for a brief about maintenance 4.0 and its requirements. The next we have to discuss the predictive maintenance and the that is known as predictive maintenance through the maintenance 4.0 technologies. And the last one is to discuss the major capability of maintenance 4.0 in various industries, how they have implemented this maintenance management to enhance the functionality of machines, equipments, and the next important part is it is how it will be support the production and operation management. Moving to next one. So these are the content of today's sessions. Introductions. The next is maintenance management. Then we have to understand Industry 4.0. Brief history about industrial revolutions, starting from the first generation to fourth generation industrial revolutions. Then we have to understand maintenance 4.0. And the next is requirement of maintenance 4.0. Then we have to understand how this maintenance 4.0 will help in case of predictive maintenance. The next we have predictive maintenance through the maintenance 4.0 technology, and we have to understand the major capability of maintenance 4.0. So these are the content of today's session. So let's understand how the industrial revolution will start and how these are basically help in case of rapid industrialization since 19th era to 2000 and 2000 to the current dates. Moving to next one. So if you go for that is known as introduction part, especially reference to the first generation of industrial revolution, which is simply known as Industry 1.0, or the second one is that is known as Industry 2.0, or the third one is that is known as Industry 3.0. The next one we have Industry 4.0. So if you goes to the generation of industries, this are directly refer to the distinct phases of industrial revolutions and how the technological changes or updates are basically enhancement, which basically dedicated for the social shifts. We have to understand this particular concept. The next one is if you go for generation of industries, these are basically of four types, as I told, that is industries 1.0, 2.0, 3.0, and 4.0, with the potential for the future industry reach 5.0. So in case of industrial, that is known as 1.0, it was initiated in the year that is known as 18th centuries. They are basically focused upon that is known as mechanizations. That means most of the mechanical components as well as the most famous part that is known as water and steam power generation is basically dedicated for these industries 1.0. The next one is industries 2.0 was started early of the that is 19th centuries. So here the rapid industrialization is basically focused upon mass productions, then generation of electricities, and most of the cases they basically go for that is known as assemble line with reference to manufacturing. The next we have that is known as industries 3.0. So this is the phase where more amount of that is known as rapid industrialization will be concerned. The first important part is that is known as development of computers. The next is automated production system should be there, or you can simply say that is known as a flexible production and operation management should be concerned. And various amount of electronics device was that is known as innovate in case of under the phases of industry 3.0. The next one is the current phases. We are basically that is known as discuss about industry 4.0. That is our topic of discussions for this particular sessions. So here we have to that is known as this particular phase is dedicated for cyber physical systems. That means large amount of information technology support should be needed. Then we are moving towards that is known as Internet of Things, which is shortly known as IoTs. Then we have established large amount of networking, and we have to learn about the new update of that is known as Industry 4.0, that is known as machine learning. So as far as concern is from industries or industrial revolution fast phase to the four phases. So if you goes to the first phases, as I told that steam and water power and mechanization should be there. Then in the second phase, in case of industries 2.0, basically dedicated for electric power generations and dedicated for mass production. Then in case of industries 3.0, dedication for automated production systems, introduction of robots, and information system support for enhancement of operations and that is known as production management. Then the current phases, Industry 4.0, is basically focused upon smart factories, those who are basically enabled through the IoTs, Internet of Things, then AI, that is artificial intelligence, and by the help of big data, they will provide large amount of accuracies in case of data analysis or data analytics to take major decisions, especially reference to industrial revolution, especially reference to problem solving. The next important part is to take the industries to different levels so that the industry will get higher side of competitive advantage when they basically adopt IoTs like technologies or artificial intelligence or maybe the big data. So these are the overview of this that is known as maintenance 4.0. Moving to next one. The next one we have that is known as the fundamental concept of Industry 4.0. So this is the topics we are going to discuss in today's session. So here they are basically focused upon internet connectivity of machine. That means it is simply referred to the condition-based monitoring where you can enable through installation of number of sensors, Wi-Fi sensors, that is IoT based cloud should be connected to the interface and interface to the number of computer so that you can easily analyze the data and take that is known as appropriate decision for problem solving or avoid any kind of that is known as breakdowns. So if you goes to point number one, the foundation of Industry 4.0 is the internet connectivity of machines. I have already told the case that condition-based monitoring was one of the best example of internet connectivity of machines. And here every step of industrial production process interact with other to adjust as per the requirements. So always function at its best. So whether you choose the technology like artificial intelligence or Internet of Things, or maybe virtual realities or assignment of number of sensors, you can also assign robotics, big data, and other, which is basically helpful for the maintenance and commonly known as maintenance 4.0. So from the beginning of industries 4.0, it is also dedicated towards using of various technologies in the form of helps to or the basic objective behind to help the maintenance department, and this maintenance is known as maintenance 4.0. So if you observe in case of nowadays, most of the automotive industries are used robotics or armed robots for painting applications, maybe assemble applications, and their accuracy is very much higher side as compared to the professional that is known as painter who are assigned previously by the industries. But the thing is that if you go for mass productions or if you go for batch productions, the precision and accuracy is very higher side if you applied that is known as armed robot or articulate robot should be assigned. Similarly, if you observe in case of the other images which is given in the slide, that in the recent era, especially reference to vehicles, they have assigned what is known as robot dog. So they basically capture the various image and the motion image specialists of various players, those who are involved in case of IPL activities. The next important part is if you go for point number three, in order to assure asset functions and value maintenance 4.0 involve comprehensive view of data sources, method to connect, way to gather, analyze, and suggest action to perform. So similarly, if you go for soft floor, large amount of that is known as box robots or articulate robots should be assigned, and they are very precisely do their work, especially dedicated for maintenance work. And in that maintenance 4.0, first important part is they collect large source of data or data sources should be there. Then the next one is method to connect and way to gather the various amount of data. Then go for analysis by the help of various known as software should be there. and if possible, they will provide large amount of supportive decisions to enhance the maintenance activities. So that is why those industries who are basically focused upon the known as four phases of industrial revolution, they are very much acquainted with maintenance 4.0, and here they are not using the different or various kind of technology, but the thing is that they will given value to their asset function. That is known as healthy life of equipment as well as to focus upon functionality of equipment as well as machines. So this is the overview. And the next important part is that is known as maintenance management. Let's understand. So we have already covered this particular part, but the thing is that whenever you talk about maintenance 4.0, you have to go for the fundamental aspect of maintenance management. So the objective of maintenance management is basically enhance the that is known as lifespan of your asset, whether it should be machines or whether it should be that is known as equipment. And the next important part is the other objectives lower the livelihood of asset failures and downtime. And the second objective is dedicated for that is known as reduce the downtime and that is known as asset failures. And plan maintenance and allocating resource effectively. The third objective of maintenance management is basically go for allocation of resources in the form of man, machine, material. And the next is they will go for proper planning of maintenance so that they can reduce the breakdown times. That is the most next objectives. The next is they are adhered to industrial regulations. So there are so many industrial regulations. In the previous session, we will discuss about the various that is known as industrial regulation with respect to ISO 9000, that rule implemented by the state government for pollutions, rule implemented by the central government for pollution. Of the next is industrial regulations are very that is important and mandated to implement inside the that is known as organization. So whenever you think about the maintenance management, especially reference to your maintenance management is very much adhered to the industrial regulation. The next important part is that is ensure the safety of our employees. This is most important part whenever you think about maintenance management. The safety precaution is the first and most important pillar of your maintenance management. So if you take care about your employees, the employee dedicatedly work for solve any kind of breakdown inside the organizations. And the last important objective is that implement better policies and procedures. So that is why if it goes to any industries across the globe, they have made their traditional standard operating procedure in a such a way that whenever a new employee or old employee involved for maintenance management work, they can easily understand if he or she maybe go through the that is known as implementation by the top level of management in the form of policy or procedures. So these are the common objective with respect to your maintenance management. So whenever you think about implementing advanced version of maintenance in the form of maintenance 4.0, in that cases you must understand these common objective with reference to maintenance management. The next important part is if it goes to the basic goals of our maintenance procedures run effectively while lowering the cost. This is another aspect of your maintenance management. Whenever you think about maintenance management, so from the top to middle to bottom level of management, they must understand how much money will be invested in case of purchase of machines, or purchase of sophisticated machines, or for purchase of flexible machine. But the thing is that you have to understand the next objective of maintenance management. It means you have to reduce the cost in every aspect. And the second one is you have to reduce the time also in case of breakdown times, in case of that is known as lower the that is known as lead time between the number of failures, and you have to allocate the resources in a such a way that you can minimize the percentage of failures and minimize the percentage of downtimes. So when you implement properly, so the maintenance management program will assist the preventing resources in the form of output. They'll reduce the wastage and equipment downtime. So, so in case of these are the we have discussed the common objective with respect to maintenance management. Let's understand what are the classification of maintenance management. So we have corrective maintenance, we have preventive maintenance, we have condition-based maintenance, we have predictive maintenance, and we have prescribed maintenance are there. So these are the five type of classification. But if you understand the process of maintenance management will start from the designs. Design to manufacturers, manufacture to maintenance plan development. Then next one we have maintenance demand. So in these cases, we'll basically take the external capacity or maybe OEM support. Operational, that is known as support, should be needed. And the other input are basically that is known as operation, operators, maintenance, internal capacity, spare part controls, rotable control should be done. And what are the results? The result is in the form of that is known as evaluation of results. And if required, it should be directly provide the feedback to the management. Again, if you are not satisfied with this particular feedback, then feedback is directly goes to the designer or the manufacturer of the particular equipment or machines. So this is the overview of your maintenance management. Whenever you think about to implement maintenance 4.0 inside your industry, you have to take care of the objectives. The next important part is the basic goals, the process, and then classification of maintenance management. Moving to next one. So next we have to understand the fundamental overview of Industry 4.0. So in case of Industry 4.0 is simply known as fourth industrial revolution or fourth phase of industrial revolutions. So this present a shift towards digital transformations in manufacturing and other industries. So in case of other industry, it is applied for large scale industries, medium scale industry, as well as small scale industries. And let's think about the different parameters or different pillar of Industry 4.0. So they have cyber securities. They have provide the solution for cyber securities. They are also provide for the known as cloud computing. So industries 4.0 have also focused upon the known as mobile technology. Through the app, you can easily control various amount of the known as condition-based maintenance or implementation of condition-based maintenance. The next is machines to machine maintenance to be done. Then 3D printing is one of the there's one is, recent technology which is introduced in case of maintenance management, especially reference to those complex part is not manufactured or not timely delivered to the maintenance department. Then they have advanced robotics are there. So I have already given the example of arm robot, how they have helped in case of assemble of automotives or painting of automotives in large scale industries, especially reference to mass production. The next is for various data, we are using big data analytics. Then Internet of Things should be there. Then RFID technology should be there. So RFID stands for radio frequency identification technologies. So it is help in case of identification of various or large amount of large volume of spare parts. Then we have cognitive, that is known as computing is there. So these are the various technological pillars which is involved in case of Industry 4.0. And what are the solution? The solution is we are shifting towards large amount of digital transformations, especially reference to manufacturing industries. So in case of Industry 4.0, it basically involves the advanced technology like Internet of Things, artificial intelligence, robotics, and big data analytics to automate and optimize the process. So if you go for automation, in that cases, you have to go for less amount of manpower, less amount of spare parts, less waste or zero waste, higher side of quality should be opted. And in case of optimize the process, automatically your raw material are simply converted to high quality product. So these are the benefits whenever you involve large amount of advanced technologies. The third point is dedicated for integration of aim to enhance the productivity. Or as a result of Industry 4.0, whenever you involve these advanced technologies, as a result, the productivity is automatically enhanced, higher side of efficiencies, higher flexibilities, enabling more intelligent decisions, especially reference to maintenance management and customizations. So these are the output of Industry 4.0 by the help of digital transformations. Moving to next one. So let's understand before one organizations or industries implementing these Industry 4.0 technologies inside the organizations. So the benefits are first one is increase efficiencies and productivities. It is due to the automations and optimization of process. And the second one is improve flexibility and agilities. That means allow faster adoption of changing market conditions and customers. So due to change in market, let's take the example of that is known as Samsung mobiles manufacturing companies versus Nokia manufacturing companies. So Samsung is very much famous due to their iOS operating systems, and they are very compatible with the Android. But it is very difficult for the initial stage of Nokia. They are not compatible with the Linux operating system. So due to the not upgrade in case of technology or flexibilities, they are still uh, not getting any kind of competitive advantage or competitive edge in the market. So due to poor performance in case of that is uh, throughout the globes, and they are facing large amount of enormous technical glitch. And Samsung has rapidly changed the technologies. So it is the best example in case of improved flexibility and agility. That means you have to allow for faster adoption of changing market condition and customers. So if you not upgrade your technology, in that cases you are not getting any competitive advantage over the customers, over the competitors. And the next important part is enhanced decision making. So due to the big data analytics, the real-time data analytics provide insight for making more informed decisions. So that is why they are vastly use artificial intelligence, that is known as machine learning technologies, to collect real-time data and analytics, which provide more insight, informed decisions whenever you go for maintenance management. The next is reduce the cost by optimizing the processes and reducing the waste. The next is improve product quality and customization. So through the higher side of automation optimizations, you can develop higher quality product and greater customization options should be available. The next is best collaboration and communication. So through the digital transformations, the digital platform and tool facilitate for better communication and collaborations. And the last one is sustainability. So whenever you talk about the sustainability, you think about the known as economic of scales, then environmental scales, and the social economic, that is or social scale. So it is basically contribute more manufacturing practices by optimizing the resource utilization and waste minimizations. So these are the benefit of Industry 4.0. And if you go for summary of Industries 4.0 in case of manufacturing industries, it increase the productivities, that is known as increase the uptimes, not downtime, increase the uptimes, optimize the inventory levels, getting higher side of competitive edge, more amount of profit margins, and the next it reduce the part of documentation record keeping. So these are the common benefits of your Industry 4.0. Moving to next ones. The next one is brief history of industrial revolutions. So as I told in the beginning of this particular sessions, these major industrial revolutions are categorized into four that is known as revolution phases. The first one is fast industrial revolution phase, second industrial phase, third industrial phase, and fourth industrial phase. So in case of fast industrial revolutions, so at this point, industry began to rely on equipments or manufacturing of goods. The next is the power looms, or in this particular phase, the power looms are developed. Carding machines, spinning molds, spinning jennies were popular technology during this time. And span and lathe, it was developed during the 70s to early 80s. This was known as the fast industrial revolutions. And the most important things dedicated to the whole world, that is known as steam engine, was introduced during this particular phase, and which was driven by the water, or that this is practice eventually gave way the steams and water's more potent equivalents. And during this period, steam engine gained popularities for several purposes. So if you observe this particular images, the first phase of that is known as steam engine was developed in the upper images, and various amount of that is known as power looms, carding machine, and spinning machines are introduced, are very popular during this phase of 70s to early 80s. So I repeat, in case of fast industrial revolutions, here it is really was a revolutions, and that is not an invention of steam machines, the use of water and steam powers, all sorted other machines, industrial transformation of society with trains. So during this particular phase, the steam engine was tested. Then mechanization of manufacturing and load of smoke should be basically introduced in this particular phase. So these are the dedications of number of technologies in the form of steam engines, the next in mechanization of manufacturing parts, then introduction of relays are basically introduced in this particular phase. The next we will discuss about it is known as second phase. So under second phase, which occurred between early 90s or late 1800 centuries to early 1900 centuries, was characterized by the rapid technological developments. So let's understand what are the most famous technology was introduced in this particular phase. So the power, or that is known as electricity generations by Benjamin Franklin was conducted an experiment to attaching metal key to kite and flown into the stormy sky. He observed the lightning electrical spark travel from the key to his hand through the damp strings. So he invented the electricities. And the next important part is this particular era saw the rise of industrializations and standardization of things interchangeable components and were need to sustain expansions. So here what will happens? So in this particular stage that is known as manufacturing and development of steels and oil industries are there. The next one is that is known as new form of business organization was developed. The next is difficult condition for industrial workers, advance in the transportation because in the previous phase the train was introduced. The next one is expansion of railway roads. Then communication revolution was started. Large factories and greater production was introduced. Massive profit for business tycoons. Emerging labor unions were established. In previous phases, there is a huge amount of difficulties. And the next is electricity was introduced during the second industrial revolutions. So these are the overview of second industrial revolutions. The next one is the third industrial revolutions. So due to quick uptake of digital electronics, if you observe in case of so that is known as smartphones, drones, cameras, laptop, desktops are introduced in this particular phase, and this phase is known as digital revolution phase. So under the third industrial revolution, which takes in the later half of 20th centuries, saw the significant that is known as technological development. As I told that microprocessor was introduced in this particular phase. Then personal computer in the form of laptop, laptops are also introduced. And the next one is smartphones was introduced by Samsung. And then there is well amount of internet connectivity throughout the globe is established. So due to the innovation technology in case of microprocessors, advanced computers, smartphones, and internet connectivity, this particular phase is simply known as digital revolution phase. The next one we have that is known as the fourth phase, which is rise to smart factories. This particular fourth phase of industries 4.0 is dedicated only for the smart factories, which enable smart sensors, predictive maintenance, utilizing machine data, then machine learnings, additive manufacturing in the form of that is known as 3D printings, all product of machines to machine communications, IoTs or Internet of Things technologies, and where appropriate at these times, people are taken out of the loops. That means if you observe this particular figure, in the industry 1.0 is dedicated for the steam engineering, then 2.0 that is for assemble lines or mass customizations of manufacturing. Then third phase that is known as computing, internet, and nuclear energy. And if you go for the fourth phases, they are categorized into three that is known as parameters. The first one is digitization and integration of value chains. The second one is that is known as digitization of product and service offering. And the third one that is known as digitization of business model and the customer access. So under this particular phase, number of that is known as softwares as well as technologies enhanced in case of mobile devices rapidly change the various technologies, especially refers to smartphones. Then organizations establish various amount of that is known as Internet of Things platforms. Then location detection technologies or tracking devices should be introduced. Advanced human-machine interface, authentication and fraud detections. Then under this industry 4.0, the most famous technology was introduced that is known as 3D printing. Then this are also enabled in case of smart sensors. Then we are using big data analytics. The multi-level customer interaction and customer profiling should be done. Augmentation of realities and cloud computing are the example of Industry 4.0. So under this Industry 4.0 involved that it is deployment of various sensors and cyber physical system. That means by the help of information technology, you will connect to various machines and equipment in case of manufacturing industries. If it goes to third point, the wide range of industrial application, including flexible automations. And the next is predictive maintenance, digital twins, and different supply chain optimizations are made possible by Industry 4.0. So currently, in case of Industry 4.0, most of the industries are go towards the supply chain management optimizations. So under supply chain management optimization, we have to focus upon product, facilities, career, and the route optimizations. So through the enable of supply chain management optimization, you can deliver very fast to number of customers, and you can collect large amount of technology information, vice versa, from company to customer and customer to companies. So these are the fundamental overview of Industry Revolution 4.0. Moving to next one. The next one is when a company is implementing that is known as Industry 4.0, they must think about that is known as Maintenance 4.0 so that the functionality as well as the lifespan of equipment and machine is automatically go for higher side. And due to this that is known as Maintenance 4.0, the organization go for enhance their productivities, increase their efficiency, and the last one is increase the product quality. So under fourth industrial revolutions, Industry 4.0 is starting the automations, digital connectivities trend that swept towards the globes, and it encompasses the big data, wireless sensors, cloud computing, artificial intelligence, machine learning, and Internet of Things. So let's take a small example of that is known as how the robotics will help in case of remote monitoring unit, which is established through the various that is known as uh, by observe various amount of condition based monitoring on machine and equipments. So if you observe the bottom figure, a Snell robot was assigned for vibration analysis, and this vibration analysis is basically done through the mobile apps. So the Snell robot is go for vibration data acquisition units. They have four layer of 1D CNN. This is a that is known as advanced version of technology which is enabled in case of Snell robots. Then vibration source mapping model should be done, and it is connected to the Wi-Fi so that the operators by using this particular app he can easily read out the all data which is collected by the Snake robot. So this is one kind of that is known as applications with reference to maintenance management. How the Snail robot is collect the data, analyze the data, and directly reflect by the help of that is known as mobile app. The next one is Industries 4.0 main focus on using technologies to link equipments, operators, processes, which helpful for maintenance. So if you observe this reshaping smart manufacturing's image, if you observe only three number of personnel should be assigned to the assemble lines, and how the assembly lines are equipped with more amount of artificial intelligence, real-time data, Ethernet, that smart maze for industries, that articulate robots and motions control should be done, smart automation should be done. So one person can easily maintain the that is known as that is the entire control of these particular things, and they're also implementing the condition based monitoring. So if you observe the first image, a person was sitting there through the smart automations, he can analyze the various data, and all the data sources are connected to the real-time deterministic Ethernet, so that anyone can easily track and that is known as observe the various amount of analysis done by the that is known as smart automation. The next is mobile robots and motions controls. Robots are basically assigned for assemble work, and they are basically use universal analog input uh, or outputs, and they have enable intelligence edge nodes so that you can easily track the different activities of your assembly lines. And the next is they are also use robot and cobots in case of known as uh, for shifting of different parts and package from manufacturing floor to the that is on the stake floors. And They are basically gone for that is a higher amount of digital connectivities through the smart automation inside the manufacturing units. So here what will happen, advanced sensors, robot, embedded softwares are features of smart factories that gathers and analyze the data to help in case of decision making. So this is the overview of your maintenance 4.0. Moving to next one. The next important part we have the knowledge what are the different technologies are basically under the maintenance 4.0. So in case of manufacturing, manufacturers may take the advantage of maintenance 4.0 by using solid data analysis, not only the forecast pattern and trend for set the scheduling maintenance and production efficient period, but also advanced to stage of automation detections, self correction or machine repairs. So for providing these kind of supports in case of production efficient periods, advanced stage of automation detection, self corrections, machine repairs, they are using vast amount of advanced technologies. So what are the technologies? So we have artificial intelligence. The next one we have Internet of Things. We have sensors. We have big data. We have cloud computing. We have robotics. We have drones. We have virtual reality or augmented realities. We have holographies and we have cyber securities. So let's understand one that is advanced technology, which is very much known as impact in our day-to-day life in in industries, that is known as artificial intelligence. So if you goes to the artificial intelligence, the aim of artificial intelligence is create the computer system capable of performing tasks that typically require human intelligence. So what are the human that is known as intelligence? That means deep learning, machine learning, neural network, natural language processing, so which is shortly known as NLPs, computer visions, cognitive computings. These are the key component which is involved as far as similar to the human intelligence, and this includes the ability for learning, problem solving, decision making, and recognize the different pattern of maintenance management. Moving to next one. The next one we are going to discuss about another technology that is known as holography and its application for 4.0 industry or maintenance 4.0. So before the that is known as representing or elaborating the holographic technologies, the next important part is that machines may carry out these duties in maintenance 4.0 because development of new link technologies which increases the machine component usable for life and prevent malfunctions. So if you go or if you applied the concept and objective of maintenance 4.0, these are dedicated for machines and the machines is basically perform the duties under maintenance 4.0. So whenever you link this particular technology with the machines, so automatically the usables life of machines and malfunction is reduced and lifespan of machine will be increased. So these are very complex systems for both peoples as well as for technologies. So the next important part is a well-designed preventive maintenance program practices, procedures, and equipment boost the likelihood of the maintenance 4.0 transition going smoothly. So for implementing of maintenance 4.0 inside the organizations, which conducted very smoothly, in that cases you have to focus upon your best practices under the preventive maintenance program, the procedure of preventive maintenance program, and the equipment who are involved under the preventive maintenance program, so that the transition should be going smoothly under maintenance 4.0. And it is similar for fully use the system of maintenance 4.0 when there is a wealth of higher quality data are required. The moment has come to begin complaining that intelligence inventories. So it is the duty of the known as maintenance manager. They are always kept eye on the optimum level of inventories. So let's take a small that is known as cases of that is known as holographic technology and how the holographic technology and its application is dedicated for maintenance 4.0 or maybe industry 4.0. So if you observe the bottom figures, you see the holographic image of a car is given. It basically shows the various parameters. So parameters of engines, parameters of entire bodies, parameters of that is known as the vibrations, the noise, the damp, the oil condition, the temperature inside the engine should be noted. And how this holographic image will help in case of industries, it is enabled through the that is known as by the application of lasers. So if you observe this particular figure, a laser is directly intended to two number of mirrors. The first mirror is known as half mirror and a full mirror is there. So they simply deflected the laser beam towards the object. So object beam is directly reflected in various form to show the graphs. And graphs in case of engine components areas, body part, rear end, front wheels, all the part. Again, they are also intended a reference beams, and this reference beam is directly induced to another mirror, and this mirror, bottom mirror, is directly reflect towards the that is known as holograph object. So the by combination of object beam and the reference beam, the entire that is known as 3D image was generated, and this 3D image is directly shown in case of desktops. So one individual is want to analyze the vibration engine. They can easily go for various parameters and check the holographic image. So through the holographic image, they can easily understand the known as condition of healthy, whether it should be healthy or face any kind of difficulties. So this kind of application is used in various industry also, especially refers to CNC machines, especially refers to ARs, automotive retrieve and reversal systems. They are also used in case of furnaces, which is used in various steel industries. Moving to next one. The next one we have that is known as requirement of maintenance 4.0. So to maintain the steady output, lower the possibility of unscheduled downtime, increase the dependabilities and availabilities, enhance product quality by keeping our asset and machinery in good conditions. So that is the common requirement for maintenance. But under the that is known as maintenance 4.0, let's understand what are the major requirements. So first important part is undergo adequate maintenance and inspections. So regular inspection is reduce the chance of breakdowns. So if you find any kind of difficulty, that difficulty is easily removed and you can provide various amount of proactive maintenance. The second one, it will be maintained with requisites components, clean, grease for better functions. So whenever you go for inspection, is required, you must go for cleaning the machines and requisites the components and also go for lubrication for better function. So it is the duty of that is known as machine operators. They will go for regular cleaning of different component of machines. If required, they go for adjustment of tightening of bolts, and if required, they go for that is known as lubrication of various component to increase the lifespan of that is machine as well as the functionalities of machine and equipments. The third point, machines that receive regular maintenance will work better and live longer. Obviously, if you regularly go for inspections, cleaning, grease, lubrications, tightening the various component boards, automatically it will function better and the lifespan of this equipment is automatically go for higher side. The next important point we have, maintenance manager can plan their budget ahead of time and make wise allocations. So whenever the maintenance management is implementing maintenance 4.0, they must go for a plan their particular budget with reference to machines, then spare parts, inventories, and they're also allocating the various amount of resources as well as they must take that is known as time management with respect to the maintenance 4.0. The fourth one, equipment performance may be tracked and maintained at the optimum level by using IoT devices. So here you have to introduce the tracking devices so that they can the machine will maintain at optimum level. One of the best example is condition-based monitoring, which is applied to observe the various that is known as condition of machines, and Currently, under maintenance 4.0, many industries are using that is known as IoT or Internet of Things devices. So the next important part is it is easier to gather substantial amount of digital data regarding the state of machineries, equipment in the context of corporate maintenance. So maintenance data is most vital. These are basically used to understand the past scenario, current scenario, and futures. And depending upon the digital data, it is basically state the machinery and equipment context with reference to corporate the maintenance activities whenever an organization is implementing maintenance 4.0. The next important part is it is solely work with physical asset, minimize the equipment uptime, working hour, and performance. So whenever you think about that is known as maintenance management, it is automatically that is known as reduce the unscheduled downtime, increase the dependabilities and availabilities, and this point is directly focus upon that is known as physical asset and minimize that is known as maximize equipment's uptimes, work hour, and the performance of the machine and equipment under maintenance 4.0. The next is use of many sensor types, including thermal cameras, vibration sensors, sound sensor, temperature sensors, and power consumption sensor has made the data collecting possible. So thermal sensors are vastly used in case of steel industries, especially for the furnaces. Then vibration sensors are also used in case of large scale industries to observe in case of from pump to motor and motor to pump. Then sound sensor are basically enable to identify and collect the various that is known as varying sound, whether the condition of varying is healthy or that is known as inefficient. Then temperature sensor is enabled in case of that is known as various high temperature area, like in case of captive power plants, the boiler components, the that is known as generator components are equipped with a more amount of temperature sensor. When the temperature is automatically rise, the sensor is directly indicate or communicate to the servers. The next is one of the most important factor of maintenance 4.0 is dedicated for that is known as utility consumption or power consumption. So that is why whenever you go for that is known as large thermal power plant or that is known as uh, hydro power plant, they are basically install large amount of that is known as power consumption sensors, and these are also providing the support to collect large set of data for analysis for better decision making. The last important that is known as requirement it is to automate the asset monitoring, efficient maintenance plannings, work order administrations, and many other processes. So these are the key requirement of the maintenance 4.0. So I repeat, first one is regular maintenance inspections. The next one is tightening the component, clean and duplications. Automatically regular maintenance will enhance your better and longer life of equipment. The next is plan the budget and make wise the allocations. The next is track and maintain the optimum level by using IoT based technologies. Then sorry, go for digital data regarding the state of machinery equipment in context of corporate the maintenance. Then solely work with the physical asset to maximize the equipment uptime, work hour, and performance. Then use of many sensors, for example, thermal, vibrations, temperature sensors. And the last one is it automate asset monitoring, efficient maintenance planning, the work order administrations, and many other processes are also included under maintenance 4.0. Moving to next one. So under maintenance 4.0, let's understand from this particular side how the predictive maintenance will help. So predictive maintenance employed the IoT sensors and predictive analysis software to check the equipment states in real time and find the indication of abnormalities, degradation that might result in failure as predicted by the softwares. So here from this particular image of a oil and gases companies or oil refinery companies, the pipeline are installed with number of sensors, and this sensor are providing the real data that is known as pH value of oil, gaseous and aqueous, that is CO2, H2S contents. Then pipelines, internal diameters and thickness data will be given by the sensor. So this data goes to the cloud, and from the cloud, the pipeline segment X is analyzed, predictions will be done, and the pipeline segment X, currently the pH and CO2 level can be lead to corrosion formings with probability of 80%. So due to higher site of carbon dioxide, it may form various amount of corrosion to the pipelines. So if the content of that is known as CO2 surpass more than that is known as 80%, in that cases they simply assign the maintenance management teams to provide the adequate and proactive or preventive solutions. If required, they go for painting work. If required, they go for welding work. If required, they go for replacement the entire pipe in case of oil supplies. So for these kind of industries, oil and refinery industries, the predictive maintenance is used in manufacturing facilities to maintain optimal productions by identify the failure modes. One of the failure mode I have explained in case of oil refineries, how the pH level and CO2 levels is lead for corrosions formings in the pipelines. And the next is the specific of what is falling and anticipation of failure dates. So the third part is dedicated this preventive or prevent equipment shutdowns by allowing the maintenance team to prepare personnel and inventory for critical repair operation as well before the expected failures. So by the help of these sensors, one can easily identify or analyze the percentage of corrosions inside the pipelines. So if required, they will assign the maintenance management teams. And the next important part is there is better collaboration in between the operation as well as the maintenance team so that they can reduce the time and increase the functionality of different components with reference to oil refineries. So to effectively foresee the issues, keep sending within the budgetary constraints. Construction business depend upon the combination of preventive and predictive maintenance. So this is the overview of predictive maintenance, how the IoT sensors they are basically assigns and how the predictive analytics software will help to analyze the percentage of pH levels and carbon dioxide level which is lead towards forming large amount of corrosions inside the pipelines. Moving to next one. The next one is dedicated for predictive maintenance through the maintenance 4.0 technologies. So if you goes to point number one, the predictive maintenance strategy that uses the data analytics tools and procedure to find the irregularities, flaw in machineries and workflow so we can correct them before they are breakdowns. So let's take the example of that is known as data analytics tools which are assigned to this particular trains. And for example, the railway train is taken as a models and they reveal the unhealthy data patterns that lead to breakage. So this information go to machine learning. Machine learning is well connected to clouds, and cloud is consist of that is known as force detectors, vision cameras, infrared sensors, acoustic sensors, and these are basically provide large set of data in case of data analytics. So by combining the machine learning data and cloud data, the operators simply shows the that is brake shoe wear probability of 50% of check brake X. So here what will happen? By the help of this that is known as unveiled data patterns, that is by the help of data analytics tools and procedure, they can easily identify the irregularities in case of brake shoes. So immediately they are understanding the machine and flow workflow so that they can correct before the breakdown will occur in case of truck trains. The next important part is the preventive maintenance leverage historical and current data for many area of business to identify the issues before they arise. And most of the cases, the industries are basically implement maintenance 4.0 for vibration analysis, oil analysis, thermal imaging, equipment monitoring are the example of preventive maintenance applications under maintenance 4.0. The next is use of IoTs for predictive maintenance have several advantages. The first one is equipment downtime may be reduced, production schedule can be kept by anticipating maintenance needs. So let's take an example of that is known as machinery, which is uh, monitored by four number of sensors, and these sensors are connected to the gateways, and that gateway is well connected to the Wi-Fi internet, and they are connected to number of that is known as clouds. So the one clouds, and this cloud has provided that is known as large amount of interface. So what are the interface? That is on feature extraction one, then artificial intelligence and machine learnings. They are basically provide the alerts. The next important part, they have data storage, multi-source sensing data fusions, and the last one is big data analytics. So as a result, by the help of computers or by the help of mobile app, you can easily track the various irregularities flaw in the machinery, so that before arise any kind of that is irregularity, that irregularity can be easily corrected. So mobile app used for predictive maintenance create additional security difficulties. Mobile devices are susceptible to cyber attacks. Confidential information about the efficiency of the equipment may be jeopardized. So that is why you can use the known as computer for analyze the various data which is enabled through the advanced IoT technologies. So this is the that is known as application of predictive maintenance through the maintenance 4.0 technologies. Moving to next one. The next one is major capability of maintenance 4.0. So major capabilities are include first one is advanced maintenance. So under advanced maintenance, the concept of maintenance 4.0 is useful for preventive maintenance, which provide advanced maintenance signals, just like through the mobile apps or through the determinants computer, you can easily identify the various signal about the irregularities, breakdowns, or that is known as any kind of difficulty arise in case of that is known as operation departments, or in case of equipment or asset breakdowns. So it basically advanced maintenance basically guard against the equipments and the asset breakdowns. The second one we have condition monitoring of industrial asset. So the effectiveness of industrial asset is assessed using condition monitoring technology via maintenance 4.0. So condition monitoring devices are known as IoT sensors may continuously record various data including temperature, vibrations, and conductivity, or that is known as thermal conductivities. The next one is notify the progress of work. So maintenance manager may notify end user of work's progress using work order management, and monitor the performance of each production asset separately is made easier with the use of work order management. It basically that is known as objective behind of notify the progress work order to reduce the downtime, fewer production gaps, cost saving are just few benefit of your IoTs. Moving to next one. The next major capability of maintenance 4.0 that is known as maintenance planning. So maintenance 4.0 is based upon the analyzing the data obtained from the sensors and other technologies. So in the previous slide, I have already given the example of that is known as how IoT based sensor will help to identify various irregularity in case of that is known as oil refinery industries. And these capacities together and analyze the vast amount of historical data, that means past data is required consistently to curate each usable information that enable the demand, production, and maintenance planning. So here maintenance planning is required the past data, especially reference to maintenance 4.0 to identify the various irregularity by assigning the sensors. And this sensor data is directly goes to the IoT clouds. By the help of various interface, you can easily identify the that is known as breakdowns, or you have to go for implementing the proactive maintenance under the maintenance 4.0. The next is save precious resources. So under maintenance 4.0 can take business to a whole new levels, and the major benefits of the company immediately, but it will provide us with the advantage of other rivals. So the space save precious resources will provide large amount of competitive advantage over the competitors who are similarly involved in this particular segment, and they are basically provide in case of offer positive and aggressive predictions. And one of the best example is big data, which provide component maintenance 4.0 along with the automation technologies. The next one we have evaluating the difficulties. So here the process for developing the mobile apps are become more automated and standardized using Industry 4.0 and cloud computing. So from the top level to bottom levels, they are vastly using various amount of apps to understand or to tracking the different activities under condition monitoring in case of maintenance management, and they are basically improve the productivity, speed up the development cycles, decrease the mistakes and defects. So most of the industrial sector maintenance 4.0 is basically added the product picker by keeping eye on the temperature of the equipment, preventing overheatings. They also conducted that is known as vibration analysis, sound analysis, oil analysis, then conduction analysis, and most of the cases they are also implementing in case of malfunction and unscheduled downtimes. So here the computer maintenance management software is very famous for evaluating the difficulties in various forms with reference to maintenance management. Moving to next one, the next one is create continuous improvement. So as far as concerned with the continuous improvement, you have to focus upon the fundamental concept of continuous improvement. That means you have to apply the PDCA cycle. I repeat, the P stand for plan, D for do, C for check, and A for act cycles. So here in these cycles under maintenance 4.0, the capability may be effectively integrate the benefit of big data IoT software for forecasting life of the equipment as well as the livelihood of failure and downtimes. So here most of the cases maintenance management are asset intensive sectors and the maintenance is very crucial in case of organizations. So as a result, you have to introduce new method, new process, new tools, new technology, new system, new software to stay competitive under maintenance 4.0. The next one is one we have that is enhanced productivity and efficiency. So by using of various that is known as mobile apps, operators collabs. Thank you.